Scientists are discovering unexpected phenomena in the latest images from the James Webb Space Telescope. These discoveries suggest that the universe might not be as we previously believed. These strange observations challenge everything we've understood so far, from dark matter to dark energy. They even touch on the very origin of the cosmic microwave background radiation. According to scientists, the Webb telescope is uncovering significant revelations. These findings could change our entire understanding of the universe. André Coetzeau, a postdoctoral researcher, stated, "We're in the business of letting the universe tell us how it works." He continues, "Maybe it's telling us it's more complicated than we thought." In this video, I'm going to break it all down for you, step by step. Trust me, it's going to blow your mind. But first, there are a few important concepts you need to understand. According to the laws of gravity, its strength weakens with distance. This principle isn't limited to our solar system. It applies universally. From stars and galaxies to massive black holes, gravity governs all. However, in the late 1900s, something unexpected happened. As scientists began observing galaxies more closely, especially in the 1970s, they noticed something strange. Astronomer Vera Rubin's work during this time was particularly revealing. They observed stars far from the centers of galaxies moving just as fast as those near the core. Scientists believed that if stars truly moved faster at galaxy edges, they would fly away into space. This is similar to how water flies off a spinning wheel, because the pull of gravity is much weaker at the outer edges of a galaxy. Yet, surprisingly, stars do not fly off into space. This unexpected speed suggests that there must be extra gravity at play. This hidden force is what scientists call dark matter. In this context, dark matter refers to an unknown force. No one knows exactly what dark matter is, or what it's made of. However, many observations indicate that it plays a crucial role in cosmic formation. Dark matter perfectly explains how the universe evolved and how cosmic structures came into existence. According to the standard model of cosmology, after the Big Bang, dark matter pulled normal matter together. Over billions of years, stars and galaxies began to form and grow inside dark matter halos. Even the large-scale structure of the universe was shaped by dark matter. Dark matter acted like an invisible framework for normal matter to clump together and form galaxies. Even the tiny temperature ripples we see in the cosmic background are influenced by dark matter. Microwave background radiation carries clear signs of dark matter's influence in the early universe. However, what the James Webb Space Telescope has recently discovered is shaking up everything we thought we knew. It's raising serious questions about dark matter itself. Either we've misunderstood dark matter completely, or perhaps it doesn't exist at all. In the latest Webb images, scientists are discovering galaxies at record-breaking distances. This means the deeper we look into the early universe, the more galaxies we're finding. It's almost like there sits no end to them. And that's a big problem for the current dark matter model, because it can't explain how such distant early galaxies could already exist. One of the most distant confirmed galaxies so far is C14. This galaxy existed when the universe was less than 280 million years old. Even more surprising, scientists have detected galaxy candidates at redshift values of 20 and beyond. This means they may have formed when the universe was just around 200 million years old. These candidates are still unconfirmed and need more testing. But if proven, they would push the limits of what our current theories can handle. What's even more shocking is the nature of these early galaxies. Some of them already look well developed, similar to our Milky Way. They're not small or chaotic like we expected. Some even contain older stars, and a few are bigger than the Milky Way itself. One galaxy named J0107A, recently discovered, is about 10 times larger than our galaxy. It existed when the universe was just a few 100 million years old. It is the largest Milky Way-like galaxy we have ever seen in the early universe. These discoveries are truly worrying. We've long believed that dark matter played a major role in galaxy formation and evolution. But now, that same dark matter theory cannot explain how these strange galaxies came into existence so early. So, either we are missing something big in our understanding of dark matter, or what we call dark matter might be something entirely different. Something that behaves in a way our current theories can't explain. But wait, those distant galaxies aren't the only problem. The James Webb Telescope has also revealed something even stranger happening in the universe, something that dark matter can't explain. Scientists have discovered that the largest cosmic structures in the universe, like galaxy clusters and vast filaments, seem to have formed differently than we previously thought. This mystery has become one of the biggest puzzles in modern cosmology. Scientists refer to it as the S8 tension. S8 is a value that tells us how much matter is clumped together in the universe, especially on very large scales. It helps explain how galaxies and galaxy clusters are spread out and how they've evolved over time. Now here's the strange part. When scientists study the early universe using data from the cosmic microwave background, they calculate a certain value for S8 based on our current standard model. When we observe the present-day universe through telescopes, we see how galaxies cluster today. Surprisingly, this observation gives us a lower value for S8. While the difference might not seem huge, it's consistent and statistically significant. This indicates that it's not just a mistake or random error. So what's going on? Some scientists suggest there's a problem with our measurements. Or more likely, something deeper and unknown is happening in the universe. The James Webb Space Telescope is raising serious doubts about dark energy. This mysterious force is believed to drive the expansion of the universe. Scientists have found major differences in how we measure the universe's expansion rate. This rate is known as the Hubble constant. When calculated using data from the cosmic microwave background, we get one value. However, measuring it with supernovae and other methods gives us a completely different value. This mismatch is known as the Hubble tension, and it's become a major challenge in modern cosmology. Here's the real twist. Recent observations suggest dark energy might not be a constant. This challenges decades of belief about the nature of dark energy. Instead, it could be something that changes over time. This is something we still don't fully understand. But hold on, it gets even more mind-blowing. There's a problem even bigger than all these cosmic tensions. Since the discovery of CMB radiation, many scientists have believed in the Big Bang theory. This theory posits that the universe had a definite beginning. The CMB was thought to be the first light from the early universe. Its properties align remarkably well with predictions made by the Big Bang model. But new research suggests the CMB might not be the afterglow of the Big Bang at all. Researchers found that what we interpreted as the oldest light might come from something else. In this study, scientists focus on early-type galaxies. These galaxies would be filled with young, hot stars that produce a lot of radiation. If enough of these galaxies packed together, their combined radiation could fill space with a glow. Over billions of years, this glow could become redshifted by the universe's expansion, until it looks exactly like the CMB we see today. This means the CMB might not actually be a remnant of the Big Bang at all. Instead, it might be the combined radiation from billions of early galaxies. The energy that these massive galaxies contribute to the overall noise in the CMB signal is not tiny. It could account for about 1.4% of the total energy in the CMB we measure today. While it's a small percentage, it significantly impacts our interpretation of the cosmic microwave background, or CMB. As we aim for more precise measurements in the future, this estimate remains conservative. If we consider all types of early galaxies, this percentage could increase even further. Should early galaxies significantly contribute to the CMB radiation, it raises crucial questions. In the extreme case that they are the main source, it destabilizes our understanding of the Big Bang. We would need to reconsider everything, from the universe's age to the formation of structures. This includes re-evaluating the physics that governed the early cosmos. The discoveries made by the James Webb Space Telescope challenge our fundamental understanding of the universe. They provoke questions about how the universe began and the nature of dark matter and energy. All the evidence that previously supported the Big Bang is now under scrutiny. These findings suggest we could be missing a vital piece of the cosmic puzzle, or the universe might be entirely different from long-held beliefs. But it doesn't end there. The Webb telescope is revealing even stranger new clues that suggest the universe might be a giant black hole. In a recent observation, scientists analyzed 30,000 galaxies through the Webb telescope. They discovered that most of these galaxies rotate in the same direction. This is unexpected because the Big Bang theory suggests chaotic formation. Galaxies should be spinning in random directions, not showing this level of uniformity. This unexpected uniformity suggests an initial spin to the universe, which current theories overlook. To support this idea, Shamir's team measured the redshift in over 30,000 galaxies. The results were astonishing, revealing larger imbalances in galaxy rotation over time. In the universe's earliest stages, galaxies were even more aligned in their rotational direction. This phenomenon is difficult to explain using current cosmological models. If these findings withstand further scrutiny, it could challenge our foundational understanding. It may even suggest physics beyond what we've learned from Einstein's theories. Following these groundbreaking revelations, a recent study proposes a new theory. Researchers from a university believe the universe might actually exist inside a black hole. They theorize that the universe was born from a massive gravitational collapse. This challenges the traditional Big Bang model of a point of infinite density. Professor Gastanega explains that matter doesn't always end in infinite density. Instead, it can reach extreme density and bounce back, creating a new expanding universe. In this theory, the edge of our universe is defined by this gravitational collapse. The universe is defined by the black hole's event horizon, a boundary that prevents us from seeing beyond it. This black hole universe concept suggests that the cosmos was not created from nothing. Rather, it is part of an ongoing cycle of collapse and rebirth, a loop that could go on forever. This theory shares similarities with conformal cyclic cosmology proposed by Nobel laureate Sir Roger Penrose. According to Penrose, the Big Bang was not the absolute beginning of everything. Instead, he proposes our universe is just one in a series of cosmic cycles. Each cycle or eon ends in a kind of stretched-out emptiness, giving birth to the next. In this view, other universes existed before ours, and more could follow after. All these discoveries and new theories are incredibly exciting and might just be the beginning. Hopefully, in the future, the James Webb Space Telescope will reveal more clues about the universe. It will help us understand how it all began. That's it for this video. We hope you enjoyed the journey.